I'm a geophysicist, and when I sit down with the raw seismic data from the Indian Ocean, I don't just see numbers on a flickering screen. I see a restless, living titan currently reshaping our world in ways we are only just beginning to comprehend. The 2004 Sumatra earthquake wasn't just a localized tragedy. It was the violent heartbeat of a planet that refuses to stay still. It was a scream from the deep, a visceral reminder of the sheer power lurking beneath the waves, forcing us to face the reality of our shifting ground. Think about the scale of that energy. We often think of the Earth as solid and permanent, a static stage where we play out our human dramas. But the data tells a completely different story. It reveals a world of constant, grinding motion, where massive slabs of rock are shoved into the furnace of the mantle, building up pressure that eventually has to find a violent outlet. We are living on a moving conveyor belt of stone and heat, and 2004 was a moment of extreme, necessary release. That outlet is what we witnessed in 2004. It was the moment when the ghost of the Sunda Trench finally spoke, breaking a silence that had lasted for centuries. It was a rupture so profound that it didn't just shake the ground, it moved the very foundation of our oceans. We have to understand that what happened then wasn't a one-off anomaly. It was the settlement of a geological debt that had been accumulating for a long time, and that debt is still being collected by the tectonic plates today. To understand the mechanics, we have to look at the Sunda Trench, a place of terrifying geological beauty. This is a subduction zone, where the Indian plate is being forced beneath the Burma plate in a slow-motion car crash that never ends. It's a grinding process occurring at a rate of just a few centimeters a year, but when that friction finally gives way, the results are catastrophic, instantaneous, and utterly transformative for the landscape, sending ripples that travel thousands of miles. Geologists call this a Megathrust event. In 2004, the seafloor didn't just slip, it snapped upward and outward with unimaginable force. Imagine a massive, jagged piece of the Earth's crust, hundreds of kilometers long, suddenly lurching toward the surface like a rising floor. This displacement of over 15 meters of rock pushed the entire water column above it into a towering wall of energy, creating a tsunami that traveled across entire oceans, demonstrating just how much the deep ocean floor can dictate the fate of the coastline. The magnitude was measured at roughly 9.1 to 9.3. To put that in perspective, it released an amount of energy equivalent to thousands of Hiroshima-sized bombs detonating simultaneously in the deep. The epicenter was about 30 kilometers below the ocean floor. But the reach of the seismic waves was global, rattling the very structure of our planet and sending vibrations through the mantle. This wasn't just a surface tremor. It was a profound reorganization of the lithospheric structure in the Indian Ocean region. This is the anatomy of a catastrophe. The stress accumulates until the rock can no longer hold, and then the elastic rebound occurs. The plates snap back to a new equilibrium, sending a shock wave through the lithosphere. It's a brutal, mechanical process of recycling the Earth's crust, and the Sunda Trench is one of the most active, high-pressure recycling centers on the entire globe. It is the Earth's furnace, and 2004 was a massive flare-up of that heat, proving how fragile our coastal stability actually is. The Earth has a long memory, and the seismic record proves it. We tend to think of these events as random, but they follow a rhythm of recurrence that is almost mathematical. The Sunda Trench is a ticking clock. It doesn't just have earthquakes, it builds them. Every rupture is just a temporary relief before the next cycle of stress begins to climb it again, a steady march toward the next inevitable breaking point. We are witnessing a cycle that has been repeating for millions of years. When we look back at the historical patterns, we see the signature of this cycle repeating over centuries. The Earth stores energy like a colossal coiled spring. When the spring uncoils, we see a massive release, but then the tension begins to build again from zero. We aren't looking at isolated incidents. We are looking at a recurring debt that the planet must periodically pay. The history of the Indian Ocean is written in these cycles, a repeating narrative of tension, build-up, and sudden, violent release. Why does this matter now? Because we are currently observing a period of significant stress accumulation in several major subduction zones. The data shows that the plates are locking into place, building up potential energy that can only be released in one way. We can see the bruising on the seafloor, where the last rupture occurred, and we know that the pressure is already mounting for the next inevitable snap. The clock is ticking, and the data suggests that the crust is reaching a critical threshold of stress. But here is where it gets truly interesting. We're starting to see correlations between these terrestrial movements and cosmic influences that many people choose to ignore. It's not just about the plates moving beneath our feet. It's about the forces acting upon the planet from above. We are looking at a complex interplay between the lithosphere and the magnetosphere, governed by celestial rhythms that connect our ground to the stars. It is a holistic view of a planet that is deeply integrated into the solar system. Consider the role of solar activity and coronal mass ejections. When a massive burst of solar plasma hits our magnetosphere, it creates a measurable ripple in the Schumann Resonance, the electromagnetic heartbeat of our planet. Some data suggests that these high-energy fluctuations can interact with the ionosphere and potentially influence the stress distribution in the Earth's crust, acting like a cosmic conductor on a geological orchestra. It suggests that the Earth is not an isolated island of rock, but a reactive body in a cosmic stream. It might sound like science fiction, but the connection is becoming increasingly measurable in our labs. We see anomalous seismic activity coinciding with peak solar cycles, suggesting that our planet isn't a closed system. It's a node in a vast cosmic web, where the energy from our sun can influence the very ground we walk on, modulating the release of tectonic stress through magnetic and electromagnetic coupling. This is the next frontier of geophysics, understanding how the heavens and the earth speak to one another. We are living on a restless machine, and the 2004 Sumatra earthquake was a warning, not a finale. The data is clear. The Earth is under constant, measurable stress. We need to stop viewing these events as just natural disasters and start seeing them as predictable geological processes. We must build our infrastructure and our awareness to withstand the inevitable. The data is screaming. We need to respect the deep earth, for it is always moving, always building, and always preparing for its next great release.